This is going to be a brief but somewhat comprehensive introduction to how our game, Remnant Odyssey, uses data structures to contain our data separately from just dragging and dropping onto the script. So, first off, we have our structs. Structs are basically a copy paste thing that you can do with code that allow you to quickly store variables together in a group. Basically, they look like this. It's a public struct. You want to serialize these and you want to make them public. Anything that is not public is only visible in the struct there. So generally, it's not advised unless you're doing specific things like putting methods in and you need interior local scale, or I fucking forget the name of what the variable is. If you need a variable inside a script, you should then keep it private. Everything else should be public and should be serialized. I even listed out here, for every struct, you want it to be system.serializable, which means you can view and edit any sort of non-base thing. So, well, a non-static, I would say. So in this case, a string, image, anything that has one of something is okay and will be displayed. Anything with a list or array will not be displayed, and dictionaries will not be displayed regardless of what you do here. So basically, if you make a new struct, serialize it so that way you can view those lists and those stuff like that, especially as you go further and further into that information. We're currently at the 145 mark here, so we're going to move on to our next part. So our struct here has the sound struct. Specifically, this is going to be comprehensive on the sound portion of this tutorial, I guess. So we have our sound struct here. Our struct has a collection name and a list of audio clips called sound file. So our sound files are associated with a collection name. So this is kind of like what we're going to do there. Next up, in our audio files, we have two separate pieces. We have a setup our dictionary, and then we have a confirmation here, console here. So all this does is this takes the struct that we already have made, or the amount of structs that we've already made. We grab its collection name, and then we grab its list of items. And in this case, you can see the list of sounds here is the new list of sounds. So it grabs this here and quickly makes a dictionary with all of those that data. So we have that. You've made it. You make your dictionary. You assign it there. Boom. So we have this dictionary of sound that we can then refer to. This sound dictionary is public because we're going to access it later. This is in a scriptable object, so I'll get to what that is specifically in a moment here. Our scriptable object looks like this. These are structs, and specifically, they are structs that store a string, the name or collection name specifically, and the sound file list. So that means that you can associate one collection name with multiple sound files. In the case of, for instance, menu music, you can put, your main menu music here. You can put your pause menu music here. You can put all of your music here, and it's associated in a small list that you can then refer to. If you really wanted to, I could make it so that way you could assign a name to each individual soundbite, but for the most part, I think we're probably going to go with the name of the audio clip, and then the audio clip will be an element, and we'll call it by the element name, which will be 0, 1, 2, whatever we decide for that. It's not the greatest. I would prefer to have a sound name rather than just a sound file list of them, but this allows us to really encapsulate our data while being super organized. So we have our menu music, we have our player music, and all of these are saved and made in the dictionary as they're going along, and you can add new elements just as you could with a list or a array just by using the plus or minus for each individual list here. So we have our actual scriptable object. It has the actual data inside of it. It has the menu, music, players, whatever else. Let's pretend those have files in them. We're going to go in, and now we're going to open up our script here again, and we're going to go to our sound manager. So our sound manager, first off, needs to make an instance of audio files. Audio files already exists. It doesn't need to be gotten. It exists as a what we call a scriptable object, so you don't need to directly reference one because there's no such thing as multiple scriptable objects in this sense. Basically, think of it like a static class. A static class is accessible from everywhere all at once, and we're going to see an example of that when we get to the next one. But basically, this class here, sound manager, mono behavior, so it's inheriting from mono behavior, has the scriptable object. It then, upon turning on, before anything else, it's going to set up the dictionary. A lot of these managers that are in this code here and similar codes, the ones that are also using this similar data structure, are going to have a setup dictionary call on their awake function. This is going to make sure that all the data is properly ready and accessible before start functions start up, which means basically all the data is saved and ready to be used before objects are actually turned on, as I would say. So that's important. So we put that as the front. Setup dictionary always comes first in any sort of away function that requires it. Next up, we have one public method. I considered adding multiple here, a trigger with animation with sound or some sort of temp functionality. I think that was actually one of yours that you ended up implementing, Flynn. But I've moved that, and you'll see that in a moment. So we have our play sound at location. It takes a sound name, specifically the collection name. I need to change that out. So that will be the collection name. An index location, so 0, 1, 2, 3, or 4, like we spoke previously, that is relevant to that list of sounds. And then the audio source. The audio source is where in the world are we playing at. We can create a new source if we want to, and we can give it a vector 3. I do not recommend doing that. I would prefer, and I'm going to request that you try to do the same, that you grab an audio source from an object. So you can grab, whenever you are using specific code, what we'll probably do is you can reference this here, and you'll give it a source. You'll probably say the gameObject.audio source, or gameObject.getComponent audio source, or you may get like a collisions audio source by doing that. So from there, we take our sounds struct. We're going to store the struct these are empty things here, so these are for when we find our struct and when we find our sound. So first off, we're going to try to find the collection name. So if we find the collection name in our dictionary, we then save the collection as the chosen struct, because what we're doing here is we're just grabbing the struct that the name is associated with, which is what a dictionary does. And then we're setting the chosen sound that we have empty right now to the sound file at index location of our chosen struct. Basically, in the most basic terms, I can try to explain this out here. I'm going to click on this. Let's say that we do this. We have this one selected here, and let's pull this up here. So let's say we're already initialized here, and we have, 2 elements in this here. So when we grab let's say we say it's collection 1, and then we say index location 2, and then we say audio source. Our audio source is our game object, whatever our sound we want to call this from. So we have these variables, they're empty. So we're going to try to find our collection name. So our collection name is main menu in this case. Main menu found. Cool. So we're going to store the struct that this main menu is in out. So our chosen struct is saved as sounds here. So there you go. Okay, so now that that's been assigned and grabbed, now we have our chosen struct, and that means we can now grab our sound file index location. Here's our sound file list, the index location 2, or in this case it's actually going to be 1, my bad. So if I say index location 1, because 0, 1, so index location 1, it's going to play this audio clip here, specifically at the source that we gave it here. And then from there, we're going to get a debug.log saying that we played it successfully. If we do not play it successfully, or if we are unable to find a value for that, we're going to do a debug.log warning, which is basically just giving these little yellow things here, saying the sound was not found in the dictionary. Sounds. Cool. All right. So we're at 10-minute mark. This is probably going to need to go on an unlisted video, but it's fine because it is fucking 3:30 in the morning. So let's continue here. So going forward, we have how the play sound at location works. For the most part, I think you saw how it was working previously with our audio files there, but now we have a way to easily access and store our data, and we have a way to call it. But this method right here still means that we can only call it from things that actually have a reference to our sound manager. Sometimes you don't want to reference the sound manager directly, either because maybe you don't have the sound manager in the scene, or maybe you do, but part of the objects are turned off, or some specific thing might be occurring that shouldn't be, or doesn't, or is occurring that shouldn't be. So in order to resolve the whole problem of not easily being able to get the sound manager or the play sound at location, because okay, I should probably say the reason I want to avoid this is because if I have to grab a script that says find, if I have to, I'm gonna write this in code, or in pseudocode here. So first, if another script wants to play this method here with this with any parameters it wants to give, it needs to first find the game object, then it needs to get the component. I'm not gonna type too good. Get the component sound manager. And then after you get the component sound manager, then use the method play sound at location. So that is a big chunk of text. You know, find game object is itself pretty hard to do occasionally, because I mean specifically you're going to be finding the game manager, then you're going to grab the you're going to use get component to find the sound manager, and then you use the method play sound at location with, I don't know, name, index, source. That's a lot of text for one line, and if you are, 2-3 indents in, that can be very difficult to really start to throw in without having a monitor that has a super wide, especially if you are, working on, I'm going to kind of replicate how I would see this here, but if you were working on a taller monitor, you'd have to actually scroll off screen to actually finish that code. So we cut it down by using something called a static class. So a static class here, brief thing here, it's got some stuff. Basically, we're going to close out some of these other things here, and we'll briefly discuss what a static class is. So a static class in this particular case is a class that exists outside of your normal classes. So some classes you inherit from and you can grab things from. Inheritance is a complex thing. We've discussed that previously. Basically, a static class is similar to an asset where it will not change depending on scenes and is basically accessible from anywhere immediately when ready. So what we're doing here is we're making a public method, meaning now everything has access to this method here. Everything. These are public static classes are very dangerous, so you need to sparingly use them. In this case, I'm using them to have global conditional methods. In this case, things would probably be like, for instance, playing sounds at locations. That is going to be a sound manager thing that we're going to do. Potentially, if we need to update some data relevant to player objects, we might do it here. And specifically about like saving data to a file or saving data to somewhere else to being read, that might be called here, and then the methods will be gone later. So in order to use global methods, specifically this class called global methods, all you need to do is reference global methods dot play sound at location. That's it. And I mean, I sent you a Discord text about this before, but I'm going to quickly go over it here. Global methods.play sound at location, give your sound, your collection name, your index location, and then your source. That is it. That's all you need to do for any line that you want to play wherever, as long as the index exists, and as long as you know the thing is there, you can check it, and this should all work phenomenally. If anything doesn't work, let me know and I will take a look at it, but brief testing has said this works properly. So how does this static void method work? Well, so any method that you intend to use in a static class that is public needs to be static. And a static method basically does the same thing a static class does. It's visible everywhere, it's accessible anywhere, and it is the same regardless of where it is. Cannot be changed, cannot be edited. It is one and done. So, in here, I'm going to break this down here. We still take our parameters because we have to. We find our sound manager, which calls this method here. We'll get to that in a moment. If the sound manager is not equal to null, we then call the sound manager, which we just stored here, play sound at location with our sound name, index, and source. Boom, boom, boom. That's it. This is how we reference it, and this is how we find those audio pieces, and then we throw them in and we play. Else, you're getting a debug log warning, which is once again a yellow thing that you'll see in the inspector that's going to say cannot play sound manager was not found. I do want to state for the record, I do not write my debug.log warnings. I use ChatGPT because ChatGPT writes much better and much more understandable debug.log warnings. I tell it roughly what I want to say, and it says, okay, I know you. So, this is how we play sound at location, but what does find sound manager do? That's the final piece of this puzzle here. We need to locate our sound manager. Our sound manager is going to be on our game manager, which should be in every scene regardless. That's why that prefab is there. That's why it's at the top. It's part of our system requirements. So that means it handles scene transitions. That means it handles a whole bunch of other stuff. But for the most part, it means it's finding, at least for this script specifically, we're finding a sound manager. So public static, we need to use it. But sorry, private static, because we need to use it and it's in a static class. It needs to be static. We are returning a sound manager. You know, you're assigning a sound manager here, and that's just the name of there. So, find the game object, game manager. It's got to go looking for it. This is the most intensive part of any scene, and is imperative that we get this loading done right, because the moment this starts up, we need this to be done. Basically, how a new scene loads is when you unload the old one, all of the awake functions are called, then all of the start functions are called, and then your scene will render what you're doing. So those things will all start at the beginning of render time. So game manager is found beforehand, so we won't be seeing much of that as long as our scene transitions work properly. If not, I will take a look at that obviously and reformat those. Our sound manager needs to be stored somewhere temporarily, or else this doesn't work. So it's great so far. So if our game manager, which we supposedly should find, is not null, meaning it's there, it exists, we use a try catch method. This is a unique method kind of used to find where code may fail or may succeed, and it depends on conditionals and stuff like that, but mainly what you're doing is you're saying, okay, if certain things are not going intentional and you might get an error or you might get a warning, this is going to try the first thing. If it fails, it's going to use a catch with an exception and save that exception as EX. You can save that as whatever you'd like. That's just what I gave it there. So we try to return the get component of game manager for sound manager. So we try to give it back the sound manager. If that return is over, this method's done. We find it, easy peasy. If it fails for any reason, meaning that our sound manager is not properly on the prefab or something is not saved properly, we get the exception saying could not find sound manager component on game manager. It gives us the exception and then gives us the stack trace and then gives us the stack trace message. What a stack trace is basically where in what line of code has gone wrong and where it is, and it'll show you and it'll walk you step by step through it. It's a really unique thing that you'll find out when you take Programming 2 at Wake Tech. For those who are also watching this video that are not doing that, they're pretty cool. Would recommend doing some research on there. And then after that, we're going to return null because, well, we need to return null. Because if it fails to return null, then, you know, obviously this doesn't play and we get our second warning here. If the game manager is, but yeah, so this is our try catch, but what if the game manager is null? Well, we have an else statement. It just says we can't find the game manager and returns null again. Both of these are bad. We shouldn't generally see them, but if they do occur, it is not impossible to see. Something I am considering still doing is playing sound at location. I'm considering giving an additional parameter for the audio volume. So that will probably be in the next rendition of this. I'm really set on this audio format here because I enjoyed immensely with how it works together. But that is the audio structure of Remnant Odyssey in a giant condensed block format, explained kind of line by line on what you should be seeing. And generally, with all of the other objects here, if I select the minimap, for instance, these are individual map datas here, and these are right now they're just called lab, but they each cover a map cover, which is our like the stuff that comes over the map cover displayed. So like this is a list of bools, and then we have like quest marker, I think, yeah, bools, literally. So these are associated here. We can discuss that in detail if you'd like to at a later time. The transitions even have their own, so they have their scene name description and transition image. This will likely be reformatted a little bit to give us a little bit more detail on specifically what. Aside from that, that is my presentation on Remnant Odyssey's fully fleshed out audio management. And at least its current planned improvements, which is notably audio volume and instancing of one-shot audio clips. So yeah, there you go. If you have any questions, feel free to either write them in the comments, because this is going to go up on a YouTube video for sure, or send me a DM on Discord. So yeah, there you go. Voila. Have a great evening. Also, it is 3:35.